So now this one, we're just at the end of the chapter, okay? And I told you this has nothing to do with pH. So we पहले recap कर लेते हैं what we did. We did this KSP thing, okay, which was if I dissolve a salt crystal in a saturated solution, okay, it dissolves. But to a certain point, at a certain point, when it becomes very, very saturated, the ions will also simultaneously get together and they'll form the crystal back again. So the process of you dissolving the salt can turn into a reversible reaction. But about normal table salts, you can try this, that you can try and dissolve it in water. It will dissolve, but to a certain extent. Okay, it will continue to dissolve. At a certain point, no matter how hard or how vigorously you stir the spoon, the salt crystals will not dissolve. That would mean that the reaction is reversible now. That it is trying to dissolve, but the ions, because there's so many ions and they're so concentrated and they're so close to each other, that they immediately join together and they form the crystal back again. Okay, so remember this KSP thing is for ionic compounds and it is for only for substances that are making a saturated solution. So it's product concentration divided by reactant concentration. The reactant over here is a solid, so you don't, I mean, you take it as a constant. You don't write that in the expression. So it's just Na plus 1 times Cl minus 1. That's what your KSP is. So for different salts, you're going to have a different KSP expression, 3 calcium ions, 2 phosphate ions. So if you do product concentration, that's calcium ion cubed, phosphate ion, that's going to be squared. Divided by the reactant concentration, which is a solid, so you don't write that. So I told you there were two questions that are going to come in the paper, and one is that they will ask you to what they'll do is they'll ask you to figure out what KSP is. And we did one example, which is that they'll give us the solubility. And I told you that solubility is the term or the word that is used for the amount of salt that has already gone into the solution. Okay, if he says aluminum hydroxide is 0.5 grams, that's the solubility. That means that's already gone into the solution. So I converted 0.5 gram per dm cube into mole per dm cube. I got 0.00641. So if I write the equation for aluminum hydroxide, solid dissolving, forming ions, so 0.0064 mole per dm cube is the amount that has gone or dissolved in the solution. Okay, and based on that, it's 1:1. I mean, this is 1 and this is 1. So these moles will be exactly the same. The concentration would exactly be the same. Cl ions would be 3 times more. So based on that, I'm able to figure out, by looking at the solubility, I'm able to figure out what your concentration of the ions are in solution. And once I have that, I have the expression, which is aluminum ion concentration, OH ion concentration cubed. I've got the values, I plug in those values, and I figure out what KSP is, which is coming out to be 4.5 times 10 power minus. It's coming out to be 4.5 times 10 power minus 8. So, ये clear है? Is this part clear?
Yes, sir.
Acha, so now the next thing is, so that what KSP is. Now the next thing is the reverse. I told you that there's going to be another question which is going to be exactly the reverse of this. So for example, it tell us that the KSP for, okay, let me Google this so I get the exact value. So they tell me the KSP for calcium phosphate, let's say. So the KSP is that's a minus 33 here, 2.07 times 10 power minus 33. That's a very small value. So the reverse question is, that KSP is given and you now have to find out the solubility, either in gram per dm cube or mole per dm cube. Now, I know that calcium phosphate, I know the formula. It's a solid and it's sparingly soluble. It's not very soluble. So it's And if it becomes concentrated, it will form a reversible reaction. Some of the ions might be dissolving. Two phosphate ions. So now I don't know what is the amount of calcium phosphate that is actually dissolving in mole per dm cube. I have no idea. So simple. I'm just going to take that X mole per dm cube dissolves. So on the other side, if that is the amount that dissolves in a saturated solution, on the other side, there's going to be 3x mole per dm cube. 3 times. Calcium would be 3 times, right? And the amount of phosphate ions that are going to be produced, that's going to be 2x mole per dm cube. ये clear है? Is this clear? सारों को clear है ये चीज? Ibrahim Halab, Isaac, is this clear?
Yes.
So that pretty much solves your question because you know the KSP expression, which is going to be calcium ion squared. No, cubed. Okay, so it's going to be calcium ions cubed and phosphate ions would be, or would be squared. अच्छा, sorry, एक second. My tab is disconnected. एक second, hold it, correct. अच्छा, okay. अच्छा, so coming back to this, okay, I know the expression. So I know the KSP value which was given. It was 2.07. So the KSP value was what? It was 2.07 times 10 power minus 3, minus 33. So now the calcium ion concentration is known. That's 3x. And the phosphate ion concentration is also known. That's 2x. So I'm going to plug those in. So it's going to be 3x. And it's going to get cubed. And that one is going to be 2x. And that's going to be squared. Okay, because the concentration was 3x and 2x. And that would make it what? It would make it 3 cubed here. That's 927, right? So 3 cubed is 27. And 27 times 4, what is 27 times 4? That's, when I do the math, it's 27. X would become 5, 2 square would be 4, and X would become 5. Okay, 3 cubed we confirm color. What is 3 cubed?
27.
Yeah, 27, right? Okay, now do the math. You just have to solve for X. So it's what? It's 2.07 exponent minus 33. And then what you're going to do is divide by 27, and then you're going to divide by 4. And then you have to, yeah, that's a lot of, yeah, you got, one second, shift. So can somebody do the math? The 5. Can somebody confirm this? X would come out to be, I mean, my X is coming out to be 1.138 times 10 power minus 7 mole per dm cube. ठीक है, that's what x is. Is this clear? ये clear है कि नहीं clear? Hala, is this clear, Ibrahim? Is this clear?
Yes.
Yes.
ठीक
Yes,
है,
sir.
that's ठीक है. So that's basically the reverse. If your KSP is known, then you want to find the solubility. You can think of it as x mole per dm cube. That's the amount that dissolves. So on the other side, that's going to be 3x, and this would come out to be 2x. And you plug in the values in the expression, and once you do that, it's you just have to solve for x. Okay, so you basic you two types of questions. Okay, they're going to be pretty straightforward. Now the next thing is there's another thing which is called the common ion effect. So what is the common ion effect? It's an effect when you that happens because all of these reactions are reversible reactions. So if AgCl, although is sparingly soluble, so it's forming Ag plus 1 aqueous, some of it is dissolving and Cl minus 1 aqueous. Now, what happens in a common ion effect is that if you add more Cl ions to your solution, the concentration of Cl ions increases, right? And it's not coming from AgCl. Maybe it's coming from some other source. So maybe NaCl was added, and the solution started producing a lot of Cl ions. And in the same solution, you have AgCl. So what happens if the Cl ion concentration increases? Where would the equilibrium shift? The equilibrium is going to shift backwards, and your solubility of AgCl will decrease. Okay, so due to common effect, I mean, the way you're going to describe is that due to common, I mean, you have to use the word, this is a critical keyword. Don't explain it in your own words. You have to use the word common ion. So due to common ion effect, if Cl ion concentration increases in solution due to any reason, then the above equilibrium shifts to the left. So the above equilibrium shifts to the left all the way. So, and that is how a lot of times crystallization happens. That if you want to push the equilibrium, and if you want to form equilibrium, form crystals, right? You somehow need to push this equilibrium backwards. And there's a number of ways of doing that. Common ion effect is one of them. So hence AgCl crystals are going to form. Okay, is this clear what common ion is, or the common ion effect is?
Yes, sir.
Okay, so that's one thing. So remember, all salts are going to be less soluble if there's a common ion present. I mean, that would apply to barium sulfate as well. If you try to dissolve barium sulfate, so another example is you try to dissolve barium sulfate in sulfuric acid. So same issue. Solubility of barium sulfate will decrease. And why would it decrease? Decreases due to, again, due to the common ion effect. Okay, so it's going to happen again. So remember that, and the next thing is they're going to ask you questions. So for example, I mean, the first question is question part 1A. So they're asking you to figure out the solubility, find solubility of AgCl. And this is exactly what the question is going to come. Find solubility of AgCl in aqueous solution. So there's just water, there's nothing else. So in aqueous solution, find the solubility. Uh, Given that KSP value is given, so let me just find or Google the KSP value of AgCl, which is going to be low as well. And that's 1.8 times 10 power minus 10. So given that you have a KSP value of 1.8 times 10 power minus 10. Now, the first part is a normal question. I mean, there's nothing complicated about it. So that's normal. So all you have to do is you've got AgCl and it's a solid. You're going to try and dissolve and make a saturated solution. So it will form what? Ag plus 1 aqueous plus Cl minus 1 aqueous. Okay, that's the first part. Now, the KSP expression would be what it's going to be? It's going to be silver ion concentration times your Cl ion concentration. Now, the trouble is we don't know what the solubility is. We don't know what the concentration is. So I'm going to assume that X mole per dm cube dissolves. So on the other side, it's 1:1. So X mole per dm cube of silver ions would be present. And X mole per dm cube of Cl ions would also be present. So my KSP value is already known. That's 1.8 times 10 power minus 10. And it's X mole per dm cube into X mole per dm cube. So basically X is what? It's 1.8 times 10 power minus 10. And I need to underroot this. Okay. So all I need to do is I need to take the end root for this. So 1.8 E minus कितना minus 13 चला गया minus 10 नहीं sorry E को ये करके जल्दी से बताए कि what do we get 1.8 times 10 power minus 10 and then I have to underroot this. So I'm getting 1.341 or 32 mole per dm cube. Actually, sorry, 10 power minus 5. It's really low. So into 10 power minus. सही है? Is this clear?
Yes, sir.
अच्छा ये आ गया 1.34. Now the other part is, so we found the solubility, which is kind of low. Now the other part is part 2 of the question. That's about the common ion effect. Now he's saying find the same solubility of AgCl in 0.1 mole per dm cube NaCl aqueous. So now he's dissolving AgCl in a solution that already, remember, aqueous ka matlab hai, it's the solution, it's already a solution. The salt has already dissolved. So again, I want to figure out the solubility of AgCl solid. I'm going to try and dissolve it in this solution, which is where there is a common ion now, which is Cl ions. So I've got Ag plus 1 aqueous, and I've got Cl minus 1 aqueous. Now, I don't know what the amount of AgCl is going to resolve. So that's X mole per dm cube. So over here, it's going to be X, and over here, it's going to be X as well. But the solution already has Cl ions. There's already 0.1 mole per dm cube Cl ions present in the solution. So the solution already has 0.1 mole per dm cube Cl ions. पहले से ही है, शुरू से ही है. It's already there. Because of NaCl. Okay, these ions are coming from NaCl. Now, since it is the same equilibrium, I'm going to use the exact same expression, the exact same value. The value of KSP was what? It was 1.8 times 10 power minus 10, which we used in the previous question. And KSP would be the concentration of the products divided by the reactant. The reactant is a solid, so you don't use that. So your KSP would be X times X plus 0.1. But the Cl ions जो है वो ज़्यादा है, ठीक है? You got X mole per dm cube coming from AgCl. And there's already, even before that, there's already 0.1 mole per dm cube present. Okay, so is this part clear that we just wrote down the KSP expression? Except the solution already has Cl ions. Is this clear? Clear है कि नहीं clear? Hala, Isaac, Rumesa, is this clear?
Yes.
Achha, now the thing is that
Yes.
so now the thing is you just have to solve for X. Well, you can further simplify this a little bit, which is okay, this X over here, it's kind of meaningless. You can remember okay, the previous X that we found out, it had a very small value, right? कितना था? It was 0.000131, right? I mean, previously when we found out X, it was a very small value. Now the new X will be even smaller because the CLN concentration has gone up, right? Because of NaCl. So the equilibrium is going to shift backwards, which is why even less amount of X will dissolve and AgCl would be even less soluble. So the point is that this X over here plus 0.1, that part is kind of irrelevant because if you add a very, very tiny value, I mean, let's suppose it's this value, 2.1. So what do you get? You're going to get 0.1, and then there's going to be 0, 0, 0, and then 1, right? Which is basically almost 0.1, right? So adding this tiny X to 0.1 would really not matter in the long run. Ye be clear? Is this part clear? But ye clear hai the solubility of AgCl will decrease because Cl ions are going up because of NaCl. And the whole equilibrium will shift backwards. So less of AgCl will be soluble, right? Less ions would come from AgCl. And X will be a very small value. Adding a very small value to a relatively bigger number is kind of a waste of time. Okay? Is this clear? ये clear है सारों को? Hala, is this clear? Ibrahim, Numesa, Isaac, is this clear?
Yes.
Yes, sir.
So it's
Sir.
1.8. So you can actually solve it like this, or you can just get rid of this extra X. So what you're going to get is X into 0.1, right? And if I take 0.1 to the other side, so what do we get? 10 power minus 1, but that's 0.1. So it's going to become 10 power minus 9, which is, so my new solubility would be 1.8 times 10 power minus 9 mole per dm cube. Okay, that's going to be my new solubility of AgCl, which is way lesser compared to the first time that we calculated. When we just had water, right? When only AgCl was dissolving and X mole per dm cube and X mole per dm cube were getting produced, the quantity of X or the solubility of AgCl came out to be a lot bigger. And now what happened was that there was already 0.1 mole per dm cube NaCl. So although AgClX mole per dm cube was still dissolving, forming X of this and X of this, but there was an extra 0.1 mole per dm cube of Cl ions that were present in the solution. So product concentration divided by your reactant concentration, that gave you uh, KSP, TK product concentration. I told you to get rid of this X, kind of irrelevant, which we did, and we found out. We found out what the answer is for X, which is way lesser now. So that's it. That's solving the question the other way around. TK, is this clear, this part?
Yes, sir.
Yes, sir.
Or it's kind of both questions. I mean, they kind of they're not that difficult. But common iron, can remember the common iron stuff. So we'll just do some KSP questions now. अच्छा, sorry, this is not KSP. शुरू में थे, बहुत एक सेकेंड. There were a lot of KSP questions in the middle. Not this. Let's see, so the pH है. Yeah, for example, this one. He's talking about Ag2S, right? So we know that you need to make an equation, Ag2S. It will dissolve. And it's going to form Ag plus 1 and 2 Ag plus 1 and 1 S minus 2 aqueous ions. You have to write the KSP expression. That's going to be Ag plus 1 concentration, and that's going to be squared. And you got S minus 2 concentration, and that's going to be power 1, right? Now that's what Ag2S is. The solubility, now remember they gave us the solubility book. And you have to calculate KSP now. So solubility is given. I'm going to do something easy because I'm going to take solubility as X. So that's the amount that dissolves in a saturated solution. So this is going to be 2X. And this one would be X, right? So that means silver ion concentration is 2X, and that's squared. And the sulfur ion concentration, that's X, and that's power 1. And that will give me 2 squared is 4, 4X cubed, right? Now I know what the solubility is. They already told me. So that is what X is, right? So I'm just going to plug that value into this expression. So it's 4 times 1.16 times 10 power minus 17. And that's getting cubed. Okay, so instead of, I just simplified things. So instead of me trying to add this value over and over again, I just took that's the solubility. I just took that as X. Did all the math in X. Plugged in X in the expression, and what the final result I got, I put in what X was. Yeah, what are we getting for this? Yeah, anyone, 1.16. Exponent minus, what's the minus 17. And then it's getting cubed किधर गया? अच्छा, so it's getting cubed, and then it's getting multiplied by 4 as well. So I get
6.24 times 10 to the power of negative 51.
negative 51, right? And they're probably going to ask for I mean, you should write the units. I don't know if they're asking for the unit. The unit for this will be concentration squared times concentration, right? So it's concentration cubed mole 3 and dm minus 9, right? So that's what KSP is. Okay, the other part is a moles question, basically. So you saying calculate the minimum volume of water needed to dissolve 1 gram of Ag2S. under standard condition. So I don't know about the minimum volume. I know the solubility over here. That this over here is the solubility, right? 1.16 times 10 power minus 17 moles per dm cube, right? So I know that if I have 1 dm cube, the amount that will dissolve, that's going to be, I mean, it's going to be this one, right? 1.16 times 10 power minus 17 moles, right? That's what solubility is, mole per dm cube, right? Or could be gram per dm cube as well. So that is the amount. Now, I'm just going to use ratios. That these many moles, it takes 1 dm cube. So 1 gram, how many moles is 1 gram? That's I would need to find the moles, which is 1 gram divided by the molar mass, which is what? Sulfur I know is 32.1. Ag I have. Is that Ag? That's, I think it's 107.9. Let me check. Silver atomic mass. Yeah, it's 107.9. Let's see, what do we get? 1 gram. How many moles is this? So it's basically 108 plus 32. So 1 divided by 140, right? 108 plus 32, that's 140. So the moles I'm getting is, Ishaq, did you try this? How many moles are you getting? Can
Oh,
somebody?
1 second. Wait, is it 109.9?
No, 107.9
Okay.
and 32.1. I think that's going to be 140, right?
Yes, 140. 7.14 times 10 to the power of negative 3.
Okay. So all you had to do was, well, they already gave us the solubility, mole per dm cube, that this is the solubility, right? So 1.16 times 10 power minus 17 moles go into 1 dm cube, right? In our case, it was 1 gram, which is this many moles. So I'm just going to use ratios and I'm going to try and figure out what X is, right? So X would come out to be point 0.7142 divided by 1.16 times 10 power minus 17, which is going to be a very small value. Or no, sorry, a very large value.
6.16 times 10 to the power of 14.
So that shows that the solubility is so low that even for dissolving 1 gram of Ag2S, you need, I mean, more than a billion dm cube of water. Is that clear? I mean, 14 is a lot bigger than a billion. It's a lot bigger. But 14 is way, way bigger than a billion. It's like a million billion. So it's so just to dissolve 1 gram of Ag2S, you probably need more water than I guess that's present in the entire solar system. So you check कर लेते हैं वो जो total mass of water. So that's नहीं solar system में 2.3 times 10 per 23 dm cube है. नहीं, that's so probably on Earth, I guess. चलो ठीक है, छोड़ो इसे. अच्छा, but is this question clear? This one?
Yes.
Clear it?
Yes, sir.
ठीक है. चलो ठीक है. So we'll continue tomorrow then, and we'll do this one equilibrium constant left, which is KPC, which is also totally a different thing. ठीक like KSP was totally different compared to the pH thing that we did, dissociation constant. Before that, we did water constant, ionic product of water, Kw. So there's one more left. There are actually two more left. One we will not do. We'll do that in a separate chapter. So we'll do that tomorrow. ठीक है? चले, okay everyone.
Okay, thank you, sir. Allah.